Hi friends, today we'll focus on the last part of the periodic trends in physical and chemical properties. The last part having the periodic trends and chemical reactivity, the relation, how it will be there, that we'll studying in this particular video. We have observed the periodic trends in certain fundamental properties such as atomic radii, atomic radius, ionic radius, ionization enthalpy, electron gain enthalpy, and valence. These are all the parts we are already studied in our previous videos. If anybody is not seen those videos, please check in the description box. All the videos are available. Please go through those videos and learn and get the knowledge. Then it will be beneficial. So now we'll continue. We know by the periodicity is related to electronic configuration in our previous chapters. We shall try to explore relationships between their fundamental properties of elements with their chemical reactivity. The atomic and ionic radii generally decreases in a period from left to right. The atomic radii and ionic radii generally decreases in a period from left to right. The ionization enthalpy increases and electron gain enthalpy become more negative across a period. Ionization enthalpy increases across a period and electron gain enthalpy become more negative across a period. In other words, we can say the ionization enthalpy of the extreme left element in a period is the least, and the electron gain enthalpy of the element on the extreme right in the highest negative. So we should know that is noble gases having completely filled shells have rather positive electron gain enthalpy values. So the ionization enthalpy of the extreme left element in a period is the least, and the electron gain enthalpy of the element on the extreme right is the highest negative. This results into high chemical reactivity at the two extremes and the lowest in the center. Thus, the maximum chemical reactivity at the extreme left, say among alkali metals, is exhibited by the loss of an electron leading to the formation of a cation, and at the extreme right among the halogens, shown by the gain of an electron forming an anion. See, this property can be related with the reducing and oxidizing behavior of the elements. Maybe this part we can study in another chapters. However, it can be directly related to the metallic and the non-metallic character of the elements. Okay, so reducing and oxidizing behavior can be directly related to the metallic and non-metallic characters of the elements. Thus, the metallic character of an element which is having highest at the extremely left decreases, and the non-metallic character increases while moving from left to right across the period. The chemical reactivity of an extreme can be best shown by its reaction with oxygen and halogens. The chemical reactivity of an element can be shown by the reactions with oxygen and halogens. Here we shall consider the reaction of elements with oxygen only. Elements on the two extremes of a period easily combine with oxygen to form oxides. Elements on two extremes of a period easily combine with oxygen to form an oxides. The normal oxide formed by the element on extreme left is the most basic. The normal oxide formed by the elements on the extreme left is most basic. Say for example, Na2O is the most basic in the normal oxide. Whereas that formed by the element on extreme left right is the most acidic one, Cl2O7. The oxides of elements in the center are amphoteric. The oxides of elements in the center are amphoteric. See, amphoteric are Al2O3 and As2O3. Whereas neutral carbon monoxide NO N2O. Okay. Amphoteric oxides behave as acidic with bases and basic with acids. Amphoteric acid behave as acidic with bases and basic with acids. This is like a vice versa case. Okay. Whereas neutral oxides have no acidic, no basic properties. How? The neutral oxides have no acidic or no basic properties. Okay. Among the transition metals, the 3D series, so transition metals nothing but 3D series only. The change in atomic radii is much smaller as compared to those representative of the elements across the period. The change in atomic radii still smaller among the inner transition metals 4F series. Inner transition metals are lying in 4F series. The periodic table. The ionization enthalpies are intermediate between those of S and P block elements. As a consequence, they are less electropositive than group 1 and group 2 metals in the periodic table. In a group, the increase in atomic and ionic radii with increase in atomic number. When the atomic radii and ionic radii increases, the naturally atomic number increases. So generally results in a gradual decrease in ionization enthalpies and a regular decrease in electron gain enthalpies in the case of main group elements. Thus, the metallic character increases down the group and non-metallic character decreases. From this we'll come to know the metallic character increases down the group and non-metallic character decreases down the group. So this trend can be related with the reducing and oxidizing properties. So in the case of transition elements, however, a reverse trend is observed. So this can be explained in the terms of atomic size and ionization enthalpy. I hope guys this part you people are understood about the periodic trends and chemical reactivity, how the fundamental properties of the elements related to the chemical reactivity. So friends, I am requesting, please, if new one is seeing this video, please subscribe the channel and support me. Thanks for watching.